Okay, so we have been working on Unit 3, which is solving equations, and Unit 6, which is working with measurements. We're going to combine them today and practice the Pythagorean theorem as well as solving any equation for an unknown when we have a variable that is squared. So some practice that we would work on will be from that quiz, and so these ones about Pythagorean theorem will help us with Pythagorean theorem, solving equations involving measurement, solving equations with area. We'll look at those. Also, you can practice with Manga High. Anything about area or Pythagorean theorem will be helpful. Okay, so big hint, we're going to be using Pythagorean theorem here. I have a right angle triangle, and I know that because of this 90 degree, and I also know two side lengths. So I'm going to use Pythagorean theorem. So I'll start by writing it down. A squared plus b squared equals c squared. And I know that c has to be the hypotenuse or the longest side. So by drawing through the 90, I know that I'm going to use 6.5 as my c. So we'll do 6.5 squared here. And let's just call this one a. Could have been b, but we're calling it a. And this is b that I don't know. So I'm going to say 2.7 squared add b squared should add to the square. So we know that relationship. All right, so if I want to solve for this, first of all, I'm looking for the value for b, right? Solve for b, or the side length. So if I'm going to try and isolate that, then I need to think about removing this 2.7 squared so that I only have b squared left. So if I want to remove 2.7 squared, then I can do that to both sides. So I'm going to subtract 2.7 squared, and here I'm going to subtract 2.7 squared. Okay. And one reason that we can decide to do this is, of course, I'm wanting the b, and I have an attachment of a squared on the b, an attachment of an add on the b. So operations of squaring and adding. Now, if we were evaluating, that is finding out a value, find value, then we use BEDMAS. But we're not finding a value here, we're solving, okay? And so solving has us doing the opposite operation. Solving is opposite, so we're going in reverse. So if I'm going in reverse, then I would start off with, do I have any subtraction? No. Do I have any addition? Yes. That's what I'm going to get rid of. So that's why I'm subtracting the 2.7 squared. Okay. Once I've got rid of that, then this of course will make 0, and so we will have b squared is equal to 6.5 squared minus 2.7 squared. Now if I look at this, it's a little bit this is all just a number, so I can actually just like simplify this value here. So I'm going to just write that, simplify, and simplify is like finding these are all number values. So I'm just going to use my calculator to do that, and I need to remember to square before I subtract. Okay, whoops, wrong button. Alright, so I want 6.5 squared, and I'm going to subtract 2.7 squared because my calculator can do all that. I say equals, so b squared is going to be 34.96. So 34.96. Oops. Okay, and we recall then that we can get rid of the squared. The way I undo a square is to square root. So now I'm going to square root 34.96, and I know that 6 squared is 36, so it's going to be a little bit less than 36. Let me check my calculator. I want to square root. Mine doesn't have a square root button. I want the inverse. So there we go. 5.91. Yep, that seems to fit along with my estimate. So 5.91 would be the length that we think this one is, 5.91, and that was approximately. Okay, so that was solving involving a square, and really the big idea there is we can undo x squared using the square root. Okay, that's what we're remembering. Whoops, sorry. So if we go back here for a second, we were using bed mass backwards. We didn't have subtraction. We did have addition. We got rid of it. After we took care of that, we didn't have any multiplication, didn't have any division, but we did have exponents. So how did we undo our exponents? In this case, we undid the exponent using the square root. Okay. Another problem. Suppose the area of this shaded figure, so just inside here, not this little white windowy parts, if that was 108, then what could I do? Well, the total area is 108, and it seems like I had a circle. So let's see the area of the circle. Circle, there we go. But I also subtracted these four. And I'm just going to call it 4 because these are obviously 1, 1, 1, and 1, right? So these are 4 units squared. So I could go to my handy dandy formula sheet, which I don't have here, just a second. Here we go, my handy dandy formula sheet, and I'm looking for the area, so I'll go down the area thing till I hit circle. So there it is, I want area equals pi r squared. So we'll come back to my note, and I'm going to use the pi r squared is what I'm using for my formula. I know that the total area is supposed to be 108, but I had subtracted 4 squares from that. So really, pi is a number, right? Pi is about 3.14. So the only thing I don't know here is r. Oh, look, it said that I needed to determine the radius. In other words, I had to find r. So if I look at this in terms of a balance, then I have some area of the circle. I've removed 4 pieces of it, and that gave me 108. So why don't I put those 4 pieces back on? So I'm going to undo the subtraction by adding 4 on both sides. So that will give me 112 is apparently pi times my radius squared. Okay, and again, thinking about undoing operations, we're sort of working backwards here from BEDMAS or SAMDEB. I undid my subtraction. I do not have any addition. I do have multiplication, so this is my next step, is to undo multiply, and of course I can do that by division. So I want to divide by, let's see, I have r squared, and that's multiplied by pi, so I'm going to divide by pi. Divide by pi, do the same thing on this side. Yeah, I don't know what it is, but this 112 is a number, and pi is also a number for my calculator, so I'll just calculate that right now. Okay, so 112, and I'm going to divide by pi, equals approximately 35.65. So I have 35.65 approximately. It was approximate because there was more numbers after it. Oops, sorry, it's not equal to pi. I canceled pi out here. Those divided away. And I have r squared. So I've made it past the multiply part. Now I'm looking, do I have any divide? No. Do I have exponents? Yes. Oh, exponents. We can get rid of an exponent of 2. I'm going to undo that with square root. So we will say 35.65 square root. Oh, my word stopped working here. I'll give it a second. 35.65, we're going to square root. We're going to square root r squared, and we will just need to do that calculation. Let's see. Calculator. 35.65, and I'm going to use, this is my square root button, yours will look a little bit different. Remembering that 36 is 6 times 6, yes, it makes sense that 5.97 is approximately my answer. So 5.97 is approximately the radius then that I have for this circle. So let's see if we drew it in here, it would be approximately there. 5.97 centimeters is what I've found. So I have solved an equation in the context of measurement. So what are you going to practice? Well, we have, oh, I've lost one, sorry. There we go. We have some Pythagorean theorem practice. I do not want you to do those first 5, please, or sorry, first 6. So we're going to start with finding the missing length using Pythagorean theorem for several of these. Document your work. If you're doing it on a whiteboard, or you can do it on explain everything and share it with me. So document your work. And we're just doing this until confident. And we also have these equations. Now these ones don't have any context. So first of all, we're going to ignore number 8 and number 6. Those ones are not helpful. So don't worry about those. But all of these are really saying, I have some number squared, it's equal to 16. So kind of, I have a square. I don't know what the length of it is, but I know the area is, this is k. I know k squared equals 16. So what would I do to find the length? That's the sort of thing we're thinking of. Sometimes, though, we have either stuff additionally added on, like this one, number 9 here, or stuff that was subtracted away, like the example that I gave you. Where we subtracted some stuff away from the circle. So we just have to undo first by deciding which part of bed mass backwards we're going to do first. So are we undoing by subtraction, undoing addition, etc. So that's your practice. And if we look at what I asked you to work on then, Pythagorean theorem, that's just straight practice. There's step practice if Pythagorean theorem is giving you difficulty. Solving equations and using area to solve, those are the ones that really are the big step that you want to be doing on your own. So let's see if I can just pull that up quickly. So here I am. I'm going to try then to use equations to solve for an unknown. Okay, so I know the area here is 3x squared. Let's just put this onto a workspace so I can document. Okay, so here's my workspace for working. I know that this is a triangle, and if I had my formula, there's my formula sheet. I want the area of a triangle, so I'm going to go here. I can use either of these. I'll use the top one, base times height divided by 2. So I'll say the area is the base times the height divided by 2. In this case, I know the area is 3, so I'm going to 3 is base times height divided by 2. But I also know, the height is the one I don't know, so I'll get rid of h, and I'll put in an x there, reminding myself that I'm multiplying. And I also happen to know that the base that height was measured from, 90 degrees, is 3. So I should be able to then put in a 3 here as well. Okay, so really, what am I doing? I'm trying to solve for x here. So solve for x. So let's see. I have the x, and attached to the x we have a multiply of 3 and a divide by 2. So you can divide, get rid of division and multiplication in the order they occur. So let's get rid of multiply by 3. So I can undo multiply by dividing by 3 and dividing by 3. Those will cancel. That becomes 1. So I have 1 is equal to x over 2. And so now the only thing attached to the x is division by 2. So I'm going to undo that by multiplying by 2 and multiplying by 2 on the other side. Those will cancel, leaving me x equals 2. So of course I could double check. Let's see. Check. If I put in 3, there's nothing on that side, but the other one was 3 times x all divided by 2. So if I put in 3 times 2 divided by 2, that does in fact give me 3. So just like my original, my area is equal to 3 on both sides. So I know I'm right. So x does equal 2, check mark. Okay. So that's the way that we can be working through problems on solving area with measurement. Okay, good luck. Make sure you talk to your partners and you can explain what you're doing.